thank you to the organizer of the PHP Conference Japan for inviting me to this great conference. I am Enrico Ezimuel, so I'm principal software engineer for Elastic, and today I would like to talk about how to program Elasticsearch with PHP. So this is the summary of my presentation. So I'm going to give you a very short introduction to Elasticsearch. And of course, we will focus on how to use Elasticsearch with PHP. We will show you how to connect to Elasticsearch, how to insert some documents to Elasticsearch, how to search it. That is the most important feature of Elasticsearch. And how to provide also some advanced feature like fuzzy search, aggregation, schema on read, and also if we have time, I will just speak about asynchronous communication. So this is an interesting feature of the PHP client, and I will just mention the future work. So let's start. What is Elasticsearch? Elasticsearch is a distributed, free, and open search and analytics engine for all types of data. So you can think about Elasticsearch like a database, a distributed database, more or less. It's scaled by design and manage any size of data. So this is very important, and this is actually one of the main reasons why a lot of people are using Elasticsearch, because it's very easy to scale it, just a simple configuration file. So it's scaled by design actually, and you can manage any size of data, petabyte of data without any problem. It's very fast, so it provides near real-time search. So this is another interesting feature, because if you have petabyte of data and you have near real-time search, this is actually very interesting, and gives you a lot of feature. It's full of feature. So you can filter data, aggregate, analyze any type of information. It's basically document oriented. So in order to store information in Elasticsearch, you need to provide information in a JSON format. And you can store whatever you want, any kind of information, logging system, user information, whatever. Technically speaking, a collection of documents is called an index. And you can think about an index like a table in a SQL database. The cool feature of Elasticsearch that is REST API oriented. That means all the interaction with Elasticsearch is provided by a REST API. So there is no client or a shell tool. So this is actually very nice in the sense that you can interact with Elasticsearch in any different scenarios with different computer languages, environment, whatever. Simple HTTP communication. For instance, if you are on a Linux machine and you have a curl is a famous HTTP client, you can actually interact with Elasticsearch with just a simple get in this case. And the localhost and 9200 is the local port, is the default port of Elasticsearch. So imagine that you have Elasticsearch installed in your localhost, in your machine. If you provide this command, this is the output that you can get it. And this is actually just a ping, an info that you are providing to Elasticsearch. And as you can see, we have a kind of information. This is a JSON, of course, because as I mentioned, the communication is, everything is in JSON. And you can have, for instance, the version number of the instance that is running. In this case, the instance is, the version is 7.12.1 and other information. So the interaction is very, very simple. Okay, but how we can actually install and run Elasticsearch? Very easy. We provide Docker images. So you have just to pull the version that you want to execute. In this case, 741, for instance. This is the command of Docker, so very pretty standard. And imagine that you want to start just a single node on your local machine. So just to start, playing with Elasticsearch, we want to have just one node. You can actually execute this command. So basically, you can run the image that you previously downloaded, specifying the port that you want to open, and actually 9200 is the default one. That's it. When you run this, you have your Elasticsearch running on your machine, so you can start interacting with Elasticsearch. There is another possibility. If you don't want to install in your machine, or if you want to play using multiple nodes, whatever, you can even use Elastic Cloud. Elastic Cloud is a software as a service provided by Elastic. You have a free trial of 14 days, so you can subscribe without any credit card requirement, of course. You can try it, and actually it provides you also a nice UI that is Kibana. So Kibana is another software, open software provided by Elastic that basically can interact with Elasticsearch using a graphic information, as you can see in the slide. Okay, but let's move to the main topics of my presentation, that is Elasticsearch and PHP. So we provide an official client that is Elasticsearch-php under the Elastic repository. So you can check it out on GitHub on packages. And this is updated and released with the Elastic Stack version. That means every time we release Elasticsearch, for instance, now it's 7.15, we release the Elasticsearch-php 7.15. So it's completely updated. Why? Because on each release we change, we add a new API, we change, the REST API, and of course the client needs to be updated. The client offers also a connection pool for cluster configuration. That means if you have a cluster with multiple nodes, you can just specify the list of IP address or domain of your nodes in the Elasticsearch-php client. And the Elasticsearch-php internally has a connection pool. That means using, for instance, by default, a round-robin algorithm is able to select the node to communicate. So basically, the traffic is spread with all the cluster. So this is a very nice, feature. As I mentioned, we update the endpoints, so the API, according to the latest version. And right now we have almost 400 APIs. So there are a lot of features that Elasticsearch gives you. Each function returns the body of the HTTP response. So basically, I will show you in a minute, but very simple. The Elasticsearch-php works with an instance that is a client. So this is an object, main object, and you can interact with the endpoint just calling the function of this object. And the name of the function is, of course, the name of the API. When you execute one function, so one endpoint, actually under the hood there is a HTTP connection, and the response is the body of the HTTP response. As you know, the body is JSON. So by default, we serialize using associative array. So we will get response as associative array. And for some API that are head operation, head as the verb of the HTTP connection. So the response is a Boolean value. So it's true or false. As I said, the body is automatically deserialized from JSON into an associative array, and this is the default behavior. But if you want, you can change it. We provide a serializer interface. So basically, you can implement whatever you want to obtain, for instance, an object of your class or whatever. In case of error, because of course there is an HTTP connection, as I mentioned, under the hood, the PHP client throws a specific exception that is inheritance from the Elasticsearch exception. So all the specific exceptions from the Elasticsearch are based with this Elasticsearch exception. But for instance, if you have a 404 exception, you will get a missing 404 exception. That is a specialization of the Elasticsearch exception. How we can actually generate all the endpoints, because of course I mentioned it's 400 endpoints, so it's quite a huge, task to update it manually. Of course, we don't do this manually. We use a code generation. And we use the REST API specification of Elasticsearch. So basically, Elasticsearch offers a specification for all the endpoints. So basically, if you click here, and when I will share the slides, you will see that this underscore and blue text are actually hyperlink. You will get the REST API specification, so you can look how the endpoints are built. And of course, we test the Elasticsearch-php client using a unit test, but also with integrational test. And we actually use the same integrational test of Elasticsearch. So there are more than 2,400 tests. So there are a lot of integration tests, because of course we want to be sure that everything is working fine. Just to give you some statistics, the Elasticsearch-php client is quite a popular project. It's more than 54 millions of download. And this is actually the graph that show you that basically is growing day by day. So we are, of course, happy about these results. Okay, let's focus on the endpoints, because as I mentioned, each API is exposed using a function. This is just a simple list, just to give you an idea. So in the left of this table, the first column, there is the Elasticsearch API. So as you can see, it's just the verb of HTTP and the path with the parameters and the name of the API. So what we did was just to expose a function with the same name of the API, in this case index. And each function, as you can see it, has only one parameter, that is $params, that contains all the parameters that the endpoints needs in order to provide the response. As you can see, there are some kind of API, the last one, where basically we collect the same topics of the API, in this case cluster. So basically cluster has a lot of different endpoints, and we collect using a namespace. So as you can see here, we provide a inner function that is a cluster that exposes the specific endpoints. So we try to to provide a very simple and clean architecture. The parameters is an associative array, $params, that can contain, according to the endpoints, different parameters. For instance, this is just a copy and paste from the source code of Elasticsearch-php, where you can see the index endpoints, and this is the comment in PHP doc, where you can see all the parameters that you can provide in order to execute the index endpoints. We also had in @c, this is a PHP doc standard, the hyperlink to the specific manual for the index API. So you can check it out from the source code. And even if you are using an IDE like, I don't know, Visual Studio Code, whatever, there is auto-completion, so you can get all this information in place. How we can install the Elasticsearch-php client, of course, using Composer. And this is the command. So you have just to require Elasticsearch/Elasticsearch package. Or you can add directly in a Composer JSON as user, and you can specify actually the version. Okay, let's focus on how to start using Elasticsearch-php. So the first step is to connect to Elasticsearch. In this example, I will use the default, the localhost and 9200 port. So we have just one node, one instance. And this is how you can connect to PHP. Basically, we need to create a client instance, and we are using the client builder. Client builder is a class of Elasticsearch-php that provides a factory design partner in order to create an instance of the object. And as you can see, we have create, set host, because we have to specify where Elasticsearch is running. And when we call build, actually, this will create an instance of Elasticsearch client. So $client will be an instance of this object. That's it. So when you have this object, you can start using the endpoints. For instance, you can want to have information about the Elasticsearch, you can call just the info. Info is an endpoint that does not need any parameter. So if we var dump the result here, of course, it's an associative array because, as I mentioned, automatically Elasticsearch-php converts the JSON into an associative array. And for instance, if we are interested in the version of the Elasticsearch instance, we just need to go inside version and number. So this is how we can access the results. Okay, imagine that we don't have just one node, but we have a couple of nodes. So we have a cluster. How we can actually connect and specify this in using Elasticsearch-php? Very simple. In a set hosts, that is plural, as you can see, we have an array. So instead of specify just one node, we can specify a list of nodes. In this case, we have 3 nodes, and that's it. So automatically, when we execute the API, Elasticsearch is able to connect, for instance, the first time to the node 1, the second time to the node 2, the third time to the node 3, the fourth time to the node 1, node 2, node 3, and so on, using a round-robin algorithm. That is the default behavior. In this case, we are just consuming an API, this example, that provides information about the health of the cluster. So we want to see if the cluster is running fine, if there are some nodes down, and so on. And this is the results. There are a lot of information, of course, but for instance, we can have the information of number of nodes that are running. In this case, 3, because we have 3 nodes running here. Okay, as I mentioned, we have a connection pool that you. So let's just start to describe how the connection pool works. So imagine that we have 3 nodes, 1, 2, and 3, where Elasticsearch is running, and these are the IP address. And we have a PHP client, so an application that wants to connect to this cluster. So we are using the configuration of the previous slide. So we configure the 3 nodes. So the first time that we execute an API, the API is executed into the node 1. The second time on the node 2, the third time on the node 3, using, as I mentioned, a round-robin algorithm. So this is basically a loop. But imagine that a node is down. So for instance, node 1 is down. Automatically, PHP is able to understand that the node 1 is down. And basically, it reduces the connection pool to use only the node 2 and the node 3. So this is done automatically. You don't have to do nothing, basically. And this is actually a very nice feature of the client, because as you can imagine, you can have a very, a complex scenario using, multiple nodes. And if you have a tool that automatically, select and, remove the node from the cluster if it's down, is a very good feature. You don't have to do by yourself. Actually, we provide also a selector interface where you can actually implement your custom algorithm for selecting the next node. As I mentioned, we have the round robin, that is the default one. We also offer a sticky round robin algorithm that uses current connection unless it's dead, otherwise it's used round robin. And we also have a random algorithm that selects the node randomly. But as I mentioned, this is an interface. So if you implement your custom algorithm, you can actually use your custom implementation. And how you can do this? You have just to specify when you build the client in the client builder, the set selector function, providing the name of the class that you implemented. That's it, very simple. If you want to connect to Elastic Cloud, that, as I mentioned, is another possibility. So you don't want to install by yourself, manage your Elasticsearch cluster, but you want just to consume as a service. Of course, when you register to the Elastic Cloud, you will get a Cloud ID and API key. These are the 2 information in order to, execute your client. And you can actually, in Elasticsearch-php, just specify when you create the instance of the client, the Elastic Cloud ID and the set API key, and build the client. That's it. So you are ready to start using Elastic Cloud. Okay. As I mentioned, Elasticsearch uses JSON. The majority of HTTP connection nowadays use JSON. And JSON, of course, is supported by PHP using 2 main functions that are JSON encode and JSON decode. starting from PHP 7.3, there is also the possibility to throw exception using JSON. So if you are using these two functions, encode and decode, if you enable with this parameter JSON throw on error, basically, if there are some error in the JSON, the function will throw an exception, that is a JSON exception. And of course, when we build the Elasticsearch-php, we use this feature because it's a very nice feature. Talking about JSON, there is one little note about empty object. So imagine that you have an empty object in JSON and you need to map it in PHP. How you can do this? Actually, you need to create an empty object in PHP. And how we can create an empty object in PHP? As you know, there is a standard class in PHP that is, as the name says, the standard class of the language. You can just create an empty object, creating an instance of this class. So when you create a new standard class, basically in JSON, this is equivalent to have an empty JSON object. Why this is important? Because there are some API like this. This is just a snapshot of a snippet code of a specific API for search in Elasticsearch, where you have to provide, as you see here, an empty object. So how you can map this empty object into an associative array? You can just actually create an empty object using the standard class as is. So the content in this case, this empty object will be translated into an empty object in JSON. So this is just a reminder that there is this difference between PHP and JSON. Okay, let's focus now on some example on how to store data into Elasticsearch. So we are ready, we have the connection in place, we want to start some information. The act of storing information is called indexing. So when you read index some document, that means storing some document into Elasticsearch. So how we can do this? We need to create, we need to use the index API, so the index function. As you can see here, we have $params. $params has a couple of parameters. You have to specify the index name that you want to use, the ID of the document. This is also optional. If you don't want, you cannot specify the ID, and Elasticsearch will automatically create an ID for you. But in this example, we provide our ID. And the last parameter is the body. So the body is basically the document in JSON that you want to put in Elasticsearch. So here you can write whatever you want. You can specify whatever you want. We just execute the index here, passing this $params, and this is the results. The results, as usual, is an associative array, and that has the result key. This is very important, where you can read the status. If you created the index, if the operation was successful or not, basically. So if you read created, means everything was fine. Okay, imagine that now you don't want to insert only one document, but you want to insert a set of documents. This is provided in Elasticsearch using the bulk indexing. So the bulk API basically provides in a single request, so a single HTTP communication, you can insert multiple documents, and Elasticsearch will store all the documents using a single HTTP request. So very, very convenient. It uses the ND-JSON format because basically if each document is a JSON, we need to provide multiple JSON in the HTTP connection, and this is named ND-JSON. So basically every document is separated by a different line. And this is how we can build the bulk API in PHP. So imagine that we want to store 100 documents using one single HTTP connection. We need to create an associative array in body. Body, as you remember, is the parameter where you put the body of your HTTP connection. Here we need to create an array because we need to create multiple documents. And actually, we need to create an array that contains two rows. The first row is the index name, as you can see here. So we need to specify the index name where we want to put the documents. And the second line is actually the document itself. So in this case, we are storing 100 documents with the same information in this example, with just a couple of two fields and two values. Very, very, very simple. So when the loop finish, basically we have in memory 100 documents into this $params body, and we can pass it to the bulk operator, and we can store the information. So very simple. The advantages is, of course, that we are, instead of indexing 100 documents, so providing 100 HTTP connection, we are just executing one HTTP connection. So from a performance point of view and also from a network traffic, this is of course the best solution. Okay, imagine now that something was wrong in the HTTP connection. For instance, you are you want to retrieve, you want to read some documents in Elasticsearch, and you have to specify, as I mentioned, the index and the ID of the documents that you want to retrieve. So here the parameters are just the index name and the ID, and you have the get endpoints to read the documents. But if the document is not stored in Elasticsearch, for instance, you provide an unknown ID, the client itself throw an exception that is missing 404 exception. So that means the document is not stored into Elasticsearch. So if you try catch the get operation, you can easily manage this, and actually you can get that message as usual as any exception with the get message exception. So this is an example just to show you how it's simple to interact with Elasticsearch-php and also manage the error. Okay, now let's jump to the, would say, the killing feature of Elasticsearch, that is actually search. For search. How we can search documents using Elasticsearch. There is a search API, and you can specify a lot of different criteria in order to in order to search your document. In this example, we are searching using the index, my index. So we are searching into this specific index, and this is actually the query. As you notice, all the information basically are regarding the documents are inside the body. So the query operation here is just a match. So we are just basically matching, searching for documents that contains this specific field that is named test field with this specific value, ABC. So this is a very simple search. We pass this parameter to the search endpoints, and this is the results. So again, it's an associative array where basically all the results are stored into the its field. So there is basically at the first level, there is an its field where you have the total results, in this case, just one document. And in order to get the documents, the results of the document, you have to iterate using this its array. So its array. In this case, we have just one element, that is the document. So this is basically the results. So if you want to read the results, you have to go inside this its parameter. There is also a nice feature of Elasticsearch-php that is using a raw JSON. What means? If you already have a JSON ready for the REST API of Elasticsearch, for instance, you copy and paste from Google, from Stack Overflow, from the manual of Elasticsearch, whatever, and you want just to pass the JSON as is without converting it into an associative array, you can do this in Elasticsearch-php. How you can do this? You have just to specify in the body, as you can see here, the body of the parameters, the string that contains the JSON. In this case, I just translated the query that I show you in the previous slide in JSON. So as you can see, this is JSON, so it's a string for PHP. you can specify in the body, and you can actually execute the parameter. So this can be, again, convenient if you have already the JSON for your REST API. Maybe you copy it from another project or another language, whatever. So this can be nice. Okay, so imagine now that you insert, I don't know, 1 million of documents in an index, and you are searching information, and you get back a lot of documents, for instance, 1,000. Of course, the REST API cannot give you in one response all the results, because 1,000 or even more documents is not possible in one single HTTP connection. So we provide the scrolling feature. So the scrolling feature is a way to paginate over many documents in the results. And we have a maximum of 10,000 each. It's more efficient than regular search because it doesn't need to maintain an expensive priority queue for ordering all the documents. So it's very convenient feature. Scrolling works by maintaining a point-in-time snapshot of the index, which is then used to page over. What means? Means basically when you search some information into Elasticsearch, Elasticsearch itself provide a snapshot of this search in order to give you the same results when you paginate over and over. Because imagine that you have a database in Elasticsearch that is updated continuously. So the frequency of the update is very high. And if you are searching information and you are paginating over and over and over, maybe the results can change because in the meantime, the information has changed in Elasticsearch. So you insert another documents and so on. So each time you want to have the information when you executed the search. So basically, when you execute the search, internally Elasticsearch provides a snapshot, and this is a point in time, basically. And this information you need to pass in the paginate in order to get the results that you get on the first search. Otherwise, you can have data that are not aligned. So basically, just focus on the example. So maybe it's more, you can understand better. So again, we want to search information in Elasticsearch. We need to use the search endpoints. You have to provide additional parameters that are the scroll, in this case 30 seconds. That is basically the time where the snapshot will live from one search to another, so 30 seconds. The size of the information, so we want to have 50 documents per page. So in each response, there will be 50 documents. And you have to, of course, provide a query. In this case, is a match all. So we are just, this is equivalent, if you think about a relational database, at select star from. We provide a search. So we expect in the dollar results 50 documents. But if we want to paginate to the other results, we need to provide a while loop until we have information inside the results. And how we can get information. As I mentioned, the results are in the its associative array. We can count if the count is greater than 0. That means the array is not empty. We can work on the results here, and we can actually scroll on the next page using the scroll feature. The only information that you need to provide here is the scroll ID and the scroll that is the timeout. The scroll ID is actually the point in time that I mentioned in the previous slide. So if you pass this ID, all the next pages will be aligned with the original search. If you don't provide the scroll ID, you can get data that are inconsistent because maybe the data in the time are changed. You can have a pagination that grows, so data are inconsistent. So this is the way to paginate over search. As I mentioned, Elasticsearch provides a lot of different features. One is the fuzzy search. What is fuzzy search? This is a cool feature that implements the Levenshtein edit distance. What is this Levenshtein edit distance? Is the distance from one string to another. It's called edit distance, and it's actually the number of one character change needed to turn one term into another. Some example. If you have the string box with a B, and you have also the string fox with the F, as you can see, the only difference from these two strings is the first letter, B and F. So the edit distance is 1 in this example, because you just need to change one character to move from box to fox. Another example, you have black string. If you remove the B, you get the lack string. So the distance between the lack and the black is another time 1, because you have to remove one character go from back to lack. Another example, insert a character. For imagine you have a seek and seek with the key. Or another example, you just swap two adjacent characters, for instance, act and cat. This is also considered one edit distance from the definition of the Levenshtein. Why I mention this? Because when you provide a search, imagine that you have a website, an e-commerce application, people sometimes, spell wrong the search name of the product or don't remember the name. This is also a very common feature in Google, where you write something, even if you write not perfectly, Google is able to give you the information back. The same idea is using the fuzzy search. So we want to create a search system in our website, for instance, that provides results even if the user didn't spell correctly the name of the product or the document that you want to search. So this is a very cool feature, actually. And how we can provide this in Elasticsearch-php? We just need to add specific parameter inside the query of the search. So this is as usual a search endpoint, the query. We need to provide that we want a fuzzy search using the doc on the doc parameters, where the value is Harry. So imagine that we have 3 documents inside our Elasticsearch with just 3 strings. The first is I will marry you because I love you. I will live with Harry. I'm sorry for your loss. Just 3 string. If we provide this query, the results will be basically from the first document, we have Harry and Mary. As you can see, the distance from Harry and Mary is just 1, because we need to change the first, just the first character. The second is 0, so because it's Harry is the same of Harry. So the first 2 documents, document 1 and document 2, will be in the results of the the fuzzy search. The last document, sorry, the last document, document 3, is actually not insert in the result because the Levenshtein distance is 2. Because from going to Harry to the sorry, that is the closest string, you need to change 2 characters. And by definition, the Levenshtein distance in Elasticsearch insert only document up to 1. So long story short, using this fuzzy search, you can get document 1 and document 2 as a result. And as you can see, document 1 is not exactly Harry, but it's very close to Harry. So maybe the user misspelled Harry and wanted Mary as well. So again, this is a very nice feature if you want to have advanced search. Elasticsearch provides you also a lot of other features. Of course, in this presentation, just give you a brief introduction. But another nice feature is the aggregation. So what means aggregation? Is to aggregate data using different metrics, statistics, or other analytics. For instance, aggregation can help you to answer a question like, what's the average load time of my website? So imagine that you are storing or the load time of your website into Elasticsearch. You can actually query Elasticsearch to give you the average load time. Or for instance, imagine that you have an e-commerce application. You can ask who are the most valuable customer based on transaction volume. So the customer that shop more on my website, or more, what could be considered a large file on my network, and so on. This kind of question. How many products we have in each product category? Just give you an example. Imagine that we have a database in Elasticsearch where we store stock market information. And we want to aggregate all the stock market using the same name, so the same stock. We can use the aggs parameter here, that is aggregate. We actually create a new result, that is my agg name. This is basically will be the results of the aggregation. So it gives the possibility to specify your name. And you have to specify the terms that you want to aggregate. In this case, imagine that we have a field that is named stock, where you have the stock options name. This is actually the field that we want to aggregate. Again, we are providing a search. And this is the results, where you can see that we have in the aggregation here, my agg name. So this is the name that you specified in the aggregation. And actually the results are under the buckets field. So this is a way to give the results of the aggregation. Another cool feature is the highlighting. So imagine that you want to provide a search and you want to highlight the term that the user wrote in the search query. This is, for instance, you have an application like this, where you have a toolbar with a search. The user write MPH, miles, basically, and you want to give all the documents that contain this text, but you want also to highlight, so to evidence this string in the results automatically. Elasticsearch is able to do this automatically, so you don't have to implement in PHP by yourself. How you can do this? You can say, okay, look, we want to, the same example of the stock option, we want to match all the stock options. This is the name of the stock options, AAL. That is actually, if I'm not wrong, American Airlines. And you have to add the highlight. So we want to have highlight, and this, okay, I want to have highlight in the name that is fields. And this is actually how you can specify the name. So we want to highlight actually the stock name. We provide the search, and actually we can iterate in the results in the hit sheets. As you can see here, we'll have the highlight name. So for each result in the document, we have this highlight name that is actually an array that contains the document. And you can, by default, Elasticsearch provide a string that is the document itself. So give you the document, and when it finds the term, it adds the M HTML tag. But if you want, you can change it using special options in the query. But this is nice because you have already the documents. You can just print the documents, and using a CSS, you can just say, for instance, the CSS M will be yellow, and so on. So this is very, very nice and convenient feature. Again, you don't have to write it in PHP. Everything is managed by Elasticsearch. Okay, another advanced feature, and this is the last that I want to show you today, is the schema on read. This is a very recent feature that we added in starting from Elasticsearch 7.12, and it introduced the ability to change schema on read using runtime fields. So this is very nice. So basically, using this option, you can create a new field that is not present into Elasticsearch, and it lives only when you read the information. So imagine that you basically want to create a query, and you want to have an aggregate information like, I don't know, the average of some field in your database. But you want to have this as a new field. This field is just returned when you have the results of your search. It's not stored into Elasticsearch. This is something basically to create on the fly, just for this specific search, a new field that change the schema This is why it's called schema on read. For instance, you can adopt it for changing the log format if you're storing log information in Elasticsearch. This is a convenient way to have a different format when you read the information. So you don't want to change the information on Elasticsearch. You just want to elaborate, create on the fly a new field with a specific format when you read the information. Or maybe you don't have a lot of information about your data that you are stored in Elasticsearch, but you want to change it on the time. So when you read information, you want to change it. Let me give you an example. Again, we are storing stock prices into a database, into Elasticsearch, and we want to create a new field that is average. That is the average of the high and low stock option. So basically, the high and low stock price are into Elasticsearch, into the documents, and we want to create a new field that is named average, that is the average of these two fields. But this field, average, is present only in the results of the query. So we don't want to store this information into Elasticsearch. How we can do this? We use search endpoints, and in the body, we need to create a runtime mapping. So this is the key in order to create schema on read. This is the name of the field that we want to create is average. The type of information is double, so it's a floating number. And actually, because we want to elaborate, we want to take different fields and use this in order to create a new one, we need a scripting language. The scripting language is named Painless in Elasticsearch, so it's very simple. In this case, the script has a source, so this is the source of the script. Emit means echo, so print the information. And as you can see here, we're just getting from the doc. Doc is the document itself. I is the name of the fields that we want to take. We want to take the value and provide the average. By definition, the average is the sum of the high and low divided by 2. So this is the average. And the name of the fields is average again. So if you send this parameter in the search, basically the response will contain the documents plus this average field that is calculated using this formula. And this can be useful in many use cases. Okay, so imagine now that you want to provide a synchronous call. So you want to execute these endpoints of Elasticsearch in PHP using an asynchronous approach. This is named the future mode in the Elasticsearch PHP, and actually we are using the future mode of Gazelle, basically. And this is a way to execute code asynchronously. For instance, this allows you to batch processing of a request, so send in parallel to the cluster, to Elasticsearch PHP cluster, many different API. So you don't have basically to wait to the response of each API. You can just execute all the API together. Internally, Gazelle at the end use the libcurl, providing a multi-interface. So there is curl is the default, adapter that is using by Elasticsearch PHP. And provides a multi-interface, so a way to execute in parallel different, HTTP connection. How we can actually start using asynchronous HTTP call using Elasticsearch PHP? Very simple. In the $params, you need to add the client parameter specifying the future lazy. So when you write future lazy here, basically, the client itself will send the API, in this case the get, using an asynchronous approach. So when you execute this line, $future will contain the future response. So this is not blocking. So basically, when you perform the get, we are not waiting for the HTTP response. This is executed and pass on. So basically, you're not blocking the execution of PHP. When you read the $future object, in this case is an array. So for instance, you want to get the source of the response. When you read the information, of course, we need to wait that the HTTP response finish, because otherwise we cannot give you the underscore source. So this is actually, in this line, you are blocking the execution. But unless you are not reading the $future, you can execute how many HTTP, how many endpoints you want in parallel. Another example, imagine that you want to create an object and you want to get, we have a client here, we want to get 1,000, we want to read 1,000 documents in parallel. So we don't want to execute each HTTP connection, but we want to execute all together. How we can do this? We can just say, okay, I want to get, because if you remember, get is the read operation. I want to read the documents using the client future lazy. And I want to store all the results in a $futures array. Okay, this loop actually executes all the HTTP in parallel, all the read in parallel. When you want to read a specific results, for instance, document number 999 on this, the last actually document on this array, you can just perform a wait. When you perform a wait, here we are blocking, we are waiting for the response of the last documents into the array. Unless you are not waiting or reading, as in the previous slide, the $future, these are executed and the PHP executed without blocking the execution. If you are interested, you can have more information in the future mode. We have more in our documentation of Elasticsearch-php. We have more information. Okay, so now I'm finishing my presentation. I would like to talk a little bit about the future work that we are doing for the next major release, that will be the 8th version that will be released next year. So next year we will have Elasticsearch 8, and we are working to offer a better Elasticsearch-php client. So a brand new PHP client, actually we are creating from scratch, because now we have the request and the response in Elasticsearch. We have the type. So we know for each endpoint how to create the request and which HTTP response we will have with the type of response. Everything is typed. So we'll have not more associative array. Of course, if you want, you can continue to use associative array, but we provide also object-oriented way to read the results and create the request. We will use PHP 8, of course, and we want to use all the cool features of PHP 8, like named arguments. That will be very nice for the endpoints. You can specify the parameters, the union type, the constructor property, promotion, and so on. So that means that Elasticsearch-php 8 will use PHP 8, so it will require PHP 8 in order to execute it. But we are in line with the end of life of PHP, because this again will be released next year. And of course, this is very important. We are going to use PSR standard. Actually, right now we are using just the PSR3 standard for logging. So this is already in place with the Elasticsearch-php 7 client that you can download it right now. But with PHP 8, we are going to use PSR 7 for HTTP messages, PR 17 for HTTP factories, and PSR 18 for HTTP client. So this is very important. We want to leverage the PSR standard. And of course, we'll continue to use asynchronous HTTP call for PHP 8. If you want to have more information about the future of Elasticsearch PHP 8, you can actually go inside this repository that contains an Elastic Transport PHP. This is a specific library that we wrote in order to use this library to connect to all the Elastic products, of course, also Elasticsearch PHP 8. And this works using PSR 7, 17, 18, the PSR standard is completely object-oriented. So I strongly encourage you to have a look just to understand how the Elasticsearch PHP will look like. Okay, I finished my presentation. Thanks for your attention. Again, if you want to have more information, you can check it out, the official documentation of Elasticsearch-php and the repository itself. Thank you.